When trying to learn VTL myself, I was frustrated that there wasn't an easy way to perform offline development. So, I found some open source code and Dockerized it. Let's see how it works. This project has very little code, but let's review it quickly. I'll clone the repository using the command shown. Next, let's enter the VTL CLI-Docker directory. Let's begin by exploring the Docker file. The base image for this project is an OpenJDK container with version 8 of the Java Runtime Environment, or JRE. This provides the core Java support necessary to run this application. I've identified myself as the maintainer using my email address. Using the arg command, we can access build arguments, allowing us to customize each build. At the time of this recording, the original creator has published 2 releases, 1.0 and 1.1. The VTL ver variable allows us to select one of those releases. We substitute the version into the wget URL string to download the proper zip file, extract the contents, then delete the zip file once complete. Last, we copy the sample directory into the container, which includes a simple example to demonstrate the tool. At the bottom, I've added a comment on how to build this container for those interested, though this should be rare. I've published this image on Docker Hub to simplify consumption. Let's explore the sample directory next. There are 2 files of interest, a variables file and a VTL template. Let's open both. The variables file is loaded into the tool to provide inputs for the template. This is a complex nested dictionary with booleans, integers, strings, and lists contained inside. The template consumes those values according to the structure defined in the vars file, which I'm showing in a callout. Based on our specific variables and the logic of the template, we should enable NTP authentication and disable NTP logging. Then, the first for loop will configure 2 NTP keys, while the second will configure 2 servers, each one using one of the NTP keys. You don't have to build your own container from the Docker file, but can instead pull from my public Docker Hub. Let's check that out quickly. I should mention that Peter Plevjonik was the original creator of VTL CLI. All I did was Dockerize it for portability. Type this docker po command to download the container, which is about 90 megabytes. I'll copy the command to my clipboard to save time. Let's head back to the dev box. At this point, let's download the container using the docker po command we saw on Docker Hub. We can confirm that it worked using the docker image ls command, which also reveals the image size. We need to create a directory named VTL mount before continuing, which I'll explain in a moment. The command to start a new container can be a bit complex, so I'll type it out first. We are running a new container with interactive shell access and mapping the VTL mount directory into the container with a bind mount. Populate your own custom DNA Center variables and templates in the VTL mount directory, and they'll be accessible within the container. Then, we specify the image that we just pulled from Docker Hub. Now, we are in the container's shell. We see the sample directory that ships with the image, the VTL mount directory we mapped using a bind mount, and a VTL executable. That's the Java program, and using the -y option, we can pass in our variables. Let's run our sample NTP template with the sample variables we explored earlier. The rendered text is written to standard output. As we expected, authentication is enabled, logging is disabled, and we have a pair of NTP keys and NTP servers. Remember, you should populate the VTL mount directory with your custom variables and templates, then use the tool on those files the same way. Coming up next, let's build some DNA Center templates.